Okay, so hello everyone. I hope you're all keeping it safe in this pandemic situation. Thank you, SECPHO, for having us here. And my name is Edgar Llop, and I am a project manager at AINIA. And in the next 10 minutes, I'll try to show you a bit of our precision agriculture technology development. But first, let me introduce a bit of what AINIA is. AINIA is a technology center in Valencia, in Spain, and we help companies to achieve a higher technology level in their production processes and activities to become more competitive in their markets. We are a non-profit association, and our government council is formed by 27 of the 742 companies associated to AINIA. We have more than 1,500 customers per year, which are mainly SMEs, but also big international companies. Originally, AINIA was a food sector technology center by originally I mean like more than 30 years ago, but year after year, AINIA opened up its scope to all the food value chain, and after that to other related sectors. So nowadays we have a strong know-how on food technology, biotechnology, nanotechnology, electronics and communication, chemical technologies, environment and energetics, and packaging, for example. And we actively work in food, energy, packaging, chemistry, cosmetics, pharma, healthcare sectors, for example. As an international company, we develop international projects in more than 25 countries all around the world. And these are some of the big figures for 2018, like when we developed 184 RD projects with a staff of more than 200 people. I think we are around 220 right now. And in 2018, we had a revenue of almost 15 million euros, and most of it, three-quarter parts, coming from private companies. Okay, so let's talk about how we develop our precision agriculture R&D through process automation technology and spectral sensor project, which is a working line of the intelligent automation department at AINIA. Most common actual approach to precision agriculture automation is based on data harvesters or data collecting sensor systems or devices such as meteo stations, drones, and satellites that will collect this information and send it to servers, either cloud or physically dedicated servers, where all this data is processed and decisions are made, and then sent to the final effectors such as farming machinery or watering systems. We work on this field, but also we work on gathering all this process and functionalities and put it on the effector point of the process, meaning that sensoring and automating farming machinery so that it can scan the crops, process information in real time, and take the best decision regarding its function. To achieve this, our main lines, we are constantly researching on new photonic technologies and adapting existing ones for better precision agriculture results. Photonic technologies like thermography, multi and hyperspectral vision, LiDAR. We also develop robotic solutions to use these photonic technologies in complex agricultural scenarios or even inside greenhouses. We use ground and aerial robots, handheld devices, cobots, all kinds of robotics that will let us work on the actual farming scenario. And our main work line is the integration of the developed technology into farming machinery like tractors and sprayers that are constantly running through the fields, and we can use that to scan the fields as they go. We develop algorithms and model based on artificial intelligence so that information captured by photonic sensors is transformed into actual decisions and execution. We work on many different crops like fruit trees, vineyards, cereal, vegetables, much more, but our main goal is to transfer this technology to the industry, like farms and plantations, or maybe the precision agriculture services providers for these farms and plantations. But most of it, we like to work with machinery manufacturers, adding up our technology to their products. So the effort put in those lines of work led us to develop high precision, low cost technology. That this technology we ship on ground and air robotic open platforms. And by open platforms, I mean that we can fully customize them depending on our customer needs or our developing projects. We ship different photonic technologies in each vehicle depending on what kind of target that we are aiming for. And also we use this technology to get very high quality and very high spatial and spectral resolution information. For example, on this little ground vehicle on the right, we can get resolutions up to 3 square millimeters per pixel hyperspectral information. As an example of our data capture and analysis capabilities, I'd like to show you these two lines of orange trees we scanned with a hyperspectral camera shipped on a drone. And since we capture a continuous spectral signature for every single pixel in this picture, we can create a classified pseudo-color image depending on the chemical composition of each picture, of each pixel of that picture. So we also work with great image resolution. Like this is a little sample of that big picture to obtain a very high spatial and spectral resolution image and detailing. In this image, this focused image, you can see that yellow color stands for orange fruit pixels, green for leaf pixels, and blue for low vegetation, and the ugly background color stands for ground pixels, attending to the chemical composition of each one of the pixels. And thanks to our robotic capabilities, we can not only do this from the top view, but also from the side view using the ground vehicle. And on top of this, we are able to generate all this in real time. Excuse me. Adding other photonic technologies like LiDAR, we can obtain a 3D physical and chemical model of every single tree and use this information to adjust watering or nutrient supplies to its needs. For example, this is one of the trees of the two lines we've seen in the previous slide. On the right, you can see the top view and the side view for some agronomical indexes like ND, water stress, chlorophyll. All this information can also be used to calculate individual fruit loads for each tree, and not only measure the quantity of the crop that will be given by this tree, but also the quality of the fruit. So this information could lead to a tree-by-tree profitability information to the harvest, for example. With all this technology, we expect to generate great benefits for those who are into precision agriculture. Benefits like nutrient and water supply optimization by monitoring agronomical indexes and water stress. So optimizing supplies most likely will reduce supplies, what means a cost saving for the harvester. Also, this information helps for the harvest planning. And as I just mentioned, the crop production estimation, both for quantity and quality of the harvesting production. We're working on detecting pests and disease. We are working so hard on this, not to predict pests and disease, but getting a real-time diagnosis of some pests, even if they are not visible to human eye, because we detect them with hyperspectral technology by their chemical signature. Being able to do this takes us to optimization of phytosanitary treatments, which on top of the money saving that means reduces the chemical contamination of the soil. And well, monitoring damage caused by meteorological phenomena, of course. So AINIA as a partner offers more than 20 years of photonic technology experience, and all the experience and equipment earned from many successful PA projects like AgriDrone and iDrone, and our actual running project series in which we are working along with 7 other companies developing a little PA unit with great capabilities. It will be able to, it's thought as a standalone unit with hyperspectral LiDAR and artificial intelligence technologies for real-time disease and pest diagnosis. We also make custom development of robotic systems for precision agriculture, and we offer technical assistance and advice.
Edgar, sorry to interrupt, just so you know, the last minute is running.
I'm about to be done.
Okay.
So most of all, we are open to collaborate in national and international projects with you. And so if you are ready to decode nature, just give us a call or send an email, and we will be so glad to chat with you. So I'm finished. So if I'm ready for any questions you may have.